4.4 applications of sinusoidal functions and their derivatives. So for the application, we need to know some concepts such as amplitude, cycle, equation of access, frequency. So if this is a sinusoidal function, know the amplitude is half the distance between the maximum and the axis, and half the distance between the maximum and minimum, or the distance between the maximum and the axis. Cycle is a distance between two symmetrical points, like maximum to maximum, or minimum, here is minimum to minimum, or maximum to maximum. Or here, the point either this point and this one, they are symmetric. The length of the full cycle, right, is the period. The equation of the axis is going to be midpoint between the maximum and minimum. Frequency is 1 over period. Now, if you have this equation, let's just see what they are. It's 50 cosine 2t plus 25. 50 here is a coefficient of the cosine, or sine is your amplitude. Here is 25 is a constant, would be equation of the axis. Somehow this 2 here is related to the period. So period is 2 pi over k. This number is k here, so it's going to be 2 pi over 2, which is pi. Pi is the equivalent for 380. Or we can say, if you want to talk about the period in degree, it's 360 over 2, right? Or k, which is 180. So it depends on what unit you want to talk about. Look at this question. An AC-DC coupled circuit produces a current described by this function. I current is equal to 60 cosine t plus 25, where t is a time second and I is the current in ampere as time c, as time t. Find the maximum and minimum current and the times at which they occur. So the maximum and minimum, we know that. We know that here is 60 because the maximum value of the cosine is plus minus 1, right? Is 60 plus minus 1 plus 25, right? When the cosine t is positive 1, so we have is 85, so it's going to be your maximum. And when the cosine is negative 1, it's going to be 60 multiplied by negative 1 is negative 60 plus 25, right? Which is 35 will be your minimum. This is one way to say cosine t is equal to positive 1, give you the maximum, and cosine t equal to negative 1 is give you the minimum. This is one way to do that. So, and you know from this circle, the cosine is x component. Here, x component is what? Here's x component is 1, so at 0 degree. Here, the x component is negative 1. Again, we go to the 160 degree, 360 degree. At this point, because this is 1, 0, and we know cosine is x component, that point, and so on, right? Cosine negative 1 is when this point here is negative 1, 0. Again, cosine is x component, so x component here is the angle is 180 degrees. If you do another full cycle, so it's going to be 360 plus 180. But assuming that you just want to discuss about the full cycle. Anyway, these are the maximum, or you could take a derivative of that and equal to 0. So what is the derivative of this? Derivative of the cosine is sine, a negative sine, and here you can negative 60 sine. At maximum, minimum is 0. Sine t is 0 at what angles? At 0, 180, 360. Again, is y component. Sine is y component. The y component is 0 here and here, which is, sorry, the y component is 0 at this point and this point, right? Which is 0 degree, 180 degree, and then go to 360. Now, just to find out which one is maximum minimum, you can bring it back into the original question. Just put 0 here, is 85, 180 is negative 35. You put 360, you get 85. So these two are your maximum, and here 180 is negative, is minimum. It's the same way that I did here. But here you use the derivative. So for a given current, determine the period. Okay, so what's the period again? The period is here is the K. Here's the K is what? Is 1. You don't see any coefficient for that. So the period is 2 pi over K. Here is 1. 2 pi. And we want to find the frequency. Frequency is 1 over period, is 1 over 2 pi. The unit of that going to be hertz. So here is second. The period, the unit of that is second. Hertz, the unit of the hertz is 1, the same as 1 over second. The amplitude, what's the amplitude? Of course, 60 will be your amplitude. And those are what it's asking for. Okay, so for the worksheet, you can do question 1, we did it in class. Question number 2, you can do. Question number 3, and question 7.